Let us write the name of this. Look at the substituents. Look at the groups attached. Nitro, chloro, nothing but halo, and a methyl. Nitro, halo, in this case, it is, of course, chloro, then methyl. All are always a substituents type. They all belong to always a substituents category. Very clear from our priority order rule. Now, in such a case, when you have always a substituents with no competition at all, when there are more than one like this, we have three things. Simply follow least sum rule. I think it is this 1, 2, 3, 4. Only when you consider this way, the sum will be 1 plus a 2 plus a 4. The other way, if considered, it will be like 1 plus, if we start from this end, it will be 1 plus 3 plus 4. So we don't go for that. We just go with this, which gives a total of 1 plus 2 plus 4, that is 7. So this numbering is proper. Now come on, let us write the name of this. Follow alphabetical order. 2-chloro. Then I think it is 1-methyl. C, then M, and finally N. 2-chloro, 1-methyl, 4-nitro. Of course, benzene, the parent. That's it. Now, this is an interesting example. See, this basically refers to anhydride. Anhydride, or you can also call it acid anhydride. What do you mean by acid anhydride? Let me say. Take acids, carboxylic acids. Let us take two such. Now from these two acids, when a water molecule is removed, minus water, that is what we call anhydride. Anhydride is nothing but without water. So now when you consider this, you will get R C double bond O, then again C double bond O, and then this R. This is the acid anhydride. In fact, this is the general formula of acid anhydride. Now, the point is whether to start giving numbers from this carbon or from this carbon is the point here. See, suppose if you start from this carbon, at the second position you got ethyl. And if suppose you start from here, at the second position, at the same second position you got Me, nothing but methyl. So both are at the second position from either sides. There is a competition between these two. When I say competition, it refers to the same position from either sides. In such a case, when there is competition, simply follow alphabetical order of priority. Because ethyl and methyl belong to the same family, alkyl family. So follow alphabetical order of priority. So which one is given priority? When alphabetical order is followed, obviously E comes first when compared to M. So let me start giving numbers from the side of E. 1, 2, 3, 4. Now the name again. At the second position, we got ethyl. At the third position, we got methyl. So we are done with the secondary prefix. 2 ethyl, 3 methyl. Now, overall, you got 4 carbons, no primary prefix because it is not cyclic. 2 ethyl, 3 methyl, but because there are 4 carbons. 1, 2, 3, 4. So this is a root word. And see, after second carbon, there is a double bond. So write butene. This is your primary suffix. Butene. You know, you got 2 carboxylic groups. That is where from you got this anhydride. So this is dioic acid, but minus water. So we call it dioic anhydride because it has come from a dioic acid. I mean 2 carboxylic groups after removing water. So let me call this butene dioic. If you want, you can even mention the numbers. Of course, it is very well understood that when there are 4 carbons, obviously they'll be at first and fourth. I mean at 2 different ends. But still, if you want, you can mention. Butene 1,4-dioic anhydride. Dioic anhydride. Anhydride is nothing but without water form. So this is a very important example. Coming to this, you know, there are 2 functional groups in this. This one is called ester. And say this one is acid halide. Now, if we check the priority order, esters are senior to acid halides. Now, this is the principal functional group and this is the substituent. Now, when you call this a principal functional group, you know, moreover, when it is connected to a cyclic one, it may be alicyclic or it may be aromatic, we use a special secondary suffix. And when this acts as substituent, you know, we call it halocarbonyl. When acid halide is treated as substituent, we call it halocarbonyl. Now, because the ester group is very important, I'm giving number 1 from here, not from this carbon as in case of a cyclic. But because this is cyclic, we don't start from here. We start from this carbon. Now, that is the first carbon and this is the second carbon. Every time when you go for cyclic, you don't start giving numbers from this, but from this. So the name of this, you know, when you write the name of an ester, the thing attached to oxygen has to be written first. I told you this 3-4 times, even earlier also. So let me write ethyl. The thing that is attached to oxygen, this is nothing but CH2, CH3. It because the 2 carbons are there. Yl because this connection is there. Ethyl. Yes, I am done with that. Then at the second carbon, we have a substituent which is called halocarbonyl. And the halogen present here is chlorine. So let me call it 2-chlorocarbonyl in place of halocarbonyl. Ethyl 2 chlorocarbonyl. You can put it in brackets. Then the parent, benzene. And the special secondary suffix for the ester. It's called carboxylate. Or otherwise from here, you can go this way also. Instead of benzene carboxylate, as per the old terminology, you can say benzoate also. If you don't find the benzene carboxylate in the answer, go for benzoate. Now the interesting point is, of course, this is a parent. Because in the parent there are 10 carbon atoms. Only the straight one has to be taken as parent chain, no other option. Because nowhere you are getting more than 10 or at least 10 carbon. So the straight one is a parent. But whether to give numbers from this end or from this end is the interesting point. See, that depends on what the names of these two are, which belong to the same family, that is alkyl family. Alkyl because you got just carbon atoms in this, no other functional groups. So depending on, because no, if suppose you give numbers from this and this carbon will get fifth number. And if suppose you give numbers from this end, this carbon will get fifth number. Means there is competition between these two. Competition in the sense occupying the same number. I mean occupying the same position, right? From the two ends. From the two ends of the carbon chain, if two things occupy the same position, we say that they are having competition. When they have competition, you have to check the names, check the names, then go for alphabetical order of priority. Let me say that these are the groups of same seniority. When I say groups of same seniority, it indicates that they belong to the same family. Same family of organic compounds. In such a case, when there is a competition, I told you what competition is, occupying the same position, then follow alphabetical order of priority. Okay. Now let us check the names of these two. Forget about giving numbers from which end. Let's see. Whatever it may be, this is something which is attached here to the parent. So either I can go this way, giving 1' and 2' numbers. The 2' can even be this way also because it is same. Either you go this way or you go this way, you are getting the same numbers. So it's 1', 2'. And at the 1' position, you got a methyl group. Now the name of this can be given as, at the 1' position, there is a methyl group. Meth, because one carbon is there, yl because of this connectivity. 1' has methyl group, and other than that side chain in the, other than that, we have 2 carbons here in the main chain of the side chain. Of course, this is a parent, this is the son, and this is a grandson. Kind of. We call this is of course a side chain or substituent, which is further substituted in the form of this methyl group. So we call it substituted substituent. 1' has methyl substituent, which is further substituted to this particular substituent, which has got 2 carbons. So 1' methyl, and in the side chain, you got two carbons. So ether and this connectivity, so aryl. Name of this is 1 prime. You know, at 1 prime you got methyl. And overall, there are two carbons. So ether, and because of this connectivity, it is aryl. The same way, let us write the name of this. If I go this way, I'll just get two carbons. No, that should not be the parent. We can go this way where we get more number of carbon atoms. Okay, now 1 prime again has a methyl group. Say this 1 prime, I mean at the 1 prime carbon, there is a methyl group. 1 prime methyl. So I'm done with this. Now I'll go for this. It has 3 carbons, so prop. And this connectivity, so aryl. This is the name. 1 prime methyl ethyl, and this is 1 prime methyl propyl. Up to 1 prime methyl, it is again common in both. But here you got E, here you got P. This clear you have to be. You know, E comes first in alphabetical order. So this carbon should get the least possible number in the competition. Giving priority according to alphabetical order is nothing but giving the least possible number. So come on, let us give numbers from this end. Forget about this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now coming to this, let me write the name 5. Again in alphabetical order also this comes first. 5, 1 prime methyl ethyl. 6, 1 prime methyl propyl. I'm done with both the substituents. Finally, dec, because 10 carbons are there in the parent. N, because single bonds are there between the carbon atoms. So this whole thing is the secondary prefix. And this is root word. And this, of course, is the primary suffix. No primary prefix because it is a cyclic. Okay. Now, let me give you some interesting points before writing the name of the same compound in a different way. Now look at this compound. See, I'm not going to give you the IUPAC name of this, but I'm going to give you something interesting. You know, this carbon, if you observe, is connected to just one carbon. I mean, it is connected to only this carbon. So let me call this carbon a primary carbon because it is just connected to only one other carbon atom. Even if it is connected to no other carbon atoms also, it is called primary carbon. Look at this. If a carbon atom is attached to one or no other carbons, one or no other carbons, it is called primary or 1 degree carbon. And hydrogens attached to it are primary or 1 degree hydrogens. So now let us see the primary carbons only at the beginning. Even this looks to be a primary one because it is connected to just one carbon. This also looks to be a primary one because it is again connected to the same carbon. Even this looks to be a primary carbon. This also is a primary. Because they all are connected to just one carbon. Even if a particular carbon is connected to no other carbons also, we call it a primary, remember. Now coming to the other thing. Now check out this carbon. Let me call it a 2-degree carbon because it is connected to one here, another onto this side by these two bonds. So if a carbon atom is connected to two other carbon atoms, then we call it 2-degree or secondary carbon. Of course, the same as the previous one, hydrogens attached to it are called secondary or 2-degree hydrogens. Now coming to this, look at this carbon. Connected to this carbon, and even this carbon also on three sides. So that's a 3-degree carbon and hydrogens attached to it. Of course, there is only one hydrogen attached. Then we call it a 3-degree carbon or a tertiary carbon. Now the final thing that is this one, look at this. See, it is connected to 4 other carbons. 1, 2, 3, and then this 4th one. So if a carbon atom is attached to 4 other carbons, it's called 4-degree or quaternary carbon. You know, there won't be any hydrogen attached to it because it is already connected to 4 other carbons and all the 4 valencies of carbon are satisfied. So it will have no hydrogens attached. So overall, let us write primary, secondary, tertiary, and quaternary carbons as well as hydrogens. I can actually see 5 1-degree carbons. Check out. Then to all the primary carbons, 3 hydrogens are attached. So overall 5 into 3, there are 15 1-degree hydrogens. Then coming to the secondary carbons, I just got one carbon, this one, and it has 2 hydrogens attached. Even there is just one tertiary carbon, it has just one hydrogen attached. One quaternary, but no hydrogens attached. This is the overall summary. Now, supposing if you got this type of an arrangement of carbon atoms in which you just got straight chain of carbon atoms. Listen to me carefully. You got straight chain of carbon atoms with a valency to be satisfied at a primary carbon. Primary in the sense which is connected to just one carbon. If there is a valency to be satisfied at primary carbon, it is called a normal compound and it is represented by N dash. Normal compound or N dash. Next. So it has just a straight chain of carbon atoms. Now look at this. See, if you have this type of an arrangement at one end, I mean a carbon attached to two other carbons this way, with no branching in between. I mean, these are all carbon atoms, but there are no branches. And if suppose there is a carbon at the other end, I mean, if you have this type of an arrangement at the other end, look at this arrangement, you remember this arrangement, a carbon connected to two other carbons. Now, this type of an arrangement is called iso arrangement. Next. See, now the point of attachment is at this carbon, which is of secondary type. So this kind of an arrangement is called a secondary arrangement and is represented by sec dash. Look at the same thing in a different way. If it has just one carbon on one end, two carbons on the other end, one carbon on one side and two carbons on the other side, then it is called secondary. Simply speaking, if there is a point of attachment at the second carbon, it is called secondary arrangement. Remember, these are all the types of arrangements. Now, coming to the fourth one. Look at this. Look at this. This is a 3-degree carbon and you got a point of connectivity at a 3-degree carbon. In such a case, it is called a tertiary arrangement. See, carbon is tertiary carbon. Arrangement is tertiary arrangement. Now, if you have this type of an arrangement at one end and this kind of an arrangement at the other end with no branching in between, this is called a neo arrangement. Neo arrangement. See, this carbon is called 4-degree. A quaternary carbon. Quaternary carbon, if at all is present, then that kind of an arrangement is called a neo arrangement. Neo arrangement. Okay. Now let me again take the same old question. Same old. Now look at this. Even this also I think is very clear. That this carbon, wherein there is a point of attachment, point of connectivity, is a 2-degree type. I mean, up to this, you forget about what is there above this. Now, this is just connected to 1 and 2. As such, it's a kind of 2-degree. Or else, see, it has one carbon at one end, two other carbons at the other end. This, we call it secondary. Secondary arrangement. If there is a carbon at one end and two carbons at the other end, we call it secondary arrangement. And because there are 4 carbons, we call it secondary butyl. Secondary butyl is the name of this. Hope you have seen the difference in the way I've written it. Coming to this, see, I've merged iso and propyl. I've written the whole thing as a single word. But here there is a gap between secondary and butyl. Moreover, I have written a capital letter here. So, remember there is a rule which says that iso and neo are treated as part of fundamental name. That means I and N are considered while arranging the whole thing in alphabetical order. So in this case, I consider I, but not P. Whereas in case of secondary and tertiary these are not treated as part of the fundamental name. Part of the fundamental name. Now look at this. So I'm not going to consider this. I am going to consider this. While arranging them in alphabetical order, I consider I in this case, B in this case. So which one comes first in alphabetical order? Obviously B, then comes I. So I'll now be giving the least possible number to this carbon, considering the B, which comes first in alphabetical order. Come on, the numbering begins from this end. So this is very interesting. Now the name of this, it's 5 secondary butyl. I am considering this B, not this S. 5 secondary butyl, 6 isopropyl. Now I am considering I, but not P. So the alphabetical order, what I have considered is B, then I. I am done with the secondary prefix now. No primary prefix because it is acyclic, not a cyclic one. Then there are 10 carbons, so dec, and single bond, so ane. So this is your root word, and this is a primary suffix. Yes. Now look at this particular compound and let us see why is it called bicyclic. Look at this. This is one ring, and this is another ring. You got two rings. One, the second one. One, the second one. One, the second one. So this is called a bicyclic compound. Now look at the same compound little more carefully. This and this. These two are common for 3 bridges. Look at this. This is one bridge consisting of this carbon and this carbon. Next, this is another bridge consisting of this, 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 and this. 4 carbons. These 4 carbons. Second bridge. And there is, of course, a third bridge also. Yes, this is a third bridge. The one that is going along this. But here you don't have any carbons in between. But that is the third bridge. So 3 bridges with 2 bridgehead atoms. The black ones are called bridgehead atoms because they are common for 3 bridges. Even this also is a bridgehead atom. So 3 bridges, 2 bridgehead atoms. Now the numbering. If this is okay, let me just give numbers to the carbons. So numbering begins first from one of the bridgehead atoms. You can go either from, starting from this carbon or this carbon. But remember, you should go first along the longest. Longest in the sense this. See, 1, 2, 3, 4 carbons are there in this bridge. If you consider this bridge, you got only 2. And in this, of course, there are no carbons. No carbons in between. So, longest is this. Next longest is this. Shortest is this. So, come on. Longest first. Let us give numbers. Starting from one of the bridge head. Let me also remove all these confusing. Now, the numbering begins at one of the bridge head. I have started giving numbers from this because I can see this, which will be at the third carbon if I start giving numbers from this carbon. If I start from this, it will be 1, 2, 3, and this will be the fourth. So you have to be this, you have to be this logical. So 1, 2, 3, 4, 5, then 6. Starting at one of the bridge head, going along the longest to the second bridge head. Now we are at the second bridge head. Now again from the second to the first bridge head. So this is the second bridge head and this is the first bridge head. Via the next longest. Longest, then next longest. Now, next longest, 7 and 8. Again to the first bridge head. And finally ending up at the shortest path, but in the shortest path, we don't have any carbon. But still, this is the order. Okay, longest, next longest, shortest. See, in the longest, you got 4 carbons. Next longest, you got 2 carbons. Shortest, you got 0 carbons. No carbons at all. Now let us check. Say this is the only functional group present. So this, of course, is principal. No substituent at all, no competition at all. So consider it as a principal functional group. And when you treat it as principal functional group, you have to call it ol. It is alcoholic group. So now, let us write the name. No substituent, so no secondary prefix. Straight away, bicyclo. Because it is a bicyclic compound. In the longest, you got 4 carbons. Next longest, 2 carbons. Shortest, 0. So these are arranged in descending order. Descending order, 4 to 0. The way we have given numbers. First along the longest, next longest, and finally shortest. 4 to 0. A total of 8 carbons are there. The root word. Then N, because single bonds are there between carbon atoms. And at the third carbon, we got ol. So because you are writing a vowel, remove this. So name of this compound is bicyclo 420 octan 3ol. Octan 3ol. This is called spiro compound. And you know, this carbon, which is common to this ring and this ring, is called common to these 2 rings. Now, this carbon is called spirocarbon. Spiro. A carbon atom which is common to both the rings is spiro. Now, interestingly, numbering here begins at, first along the shortest or the smallest ring. So smallest in the sense this, because it has 1, 2, 3, 4 carbons. Whereas I call this the longest because it has 1, 2, 3, 4, and 5. Only 2 rings. First along the smallest, then along the longest or the largest. So first along the smallest, but interestingly, numbering begins not at the spiro, but at the carbon adjacent to spiro. This is where you have to start giving numbers. The carbon atom which is adjacent to spiro. Yes. Now to the spiro. No problem, you can go this way or this way because you don't have any substituent or functional group. I just go with this. Doesn't make any difference. Yes, we are done. See, at the second carbon, there is a substituent, 2-chloro. This is halo, which is, of course, always a substituent type. So let me write it at a secondary prefix area. I'm done. 2-chloro, then write a spiro. Now, just as the numbering is given, first, the number of carbon atoms in the smaller ring, then the number of carbon atoms in the larger ring with a dot. It is not comma. Even in the previous case also. In case of bicyclo also, we have written dot, not comma. Now here they are in ascending order, not the descending order. 4.5. Overall, you got 10 carbon atoms, so dec. Then ane. Dec is the root word. Ane is a primary suffix. See, this is the spirocarbon, which is common to both the rings. Now, though you look at the chlorine here, should not go first along the longest ring or the largest ring. No, that is against the rules. We have to again start at the carbon atom adjacent to spiro only. Yes, this is spiro. Either you can start here or here. But remember, you have to start only at the carbon adjacent to spiro, point number 1. Point number 2, first along the smallest. So I'm going this way. Now, coming to this third one. But now I'll go this way because I'll get chlorine containing carbon if I go that way rather than going in this way. At the least possible number, 4, and then I'll get 5. If I go this way, it will be at the 6th position. So I don't go that way. I think I'm done. See, 5th carbon has chloro. So my secondary prefix is done. Secondary prefix. Now, come on, spiro. The smaller ring has 2 carbons, so 2 dot. The larger one has, here in the smaller you got 2 carbons. The larger one has 4 carbons. 2.4. In the ascending order, 2.4, a total of 7 carbons. So hept. Then single bonds between carbon atoms, ane. So this is the root word. This is a primary suffix. No secondary suffix because there is no functional group at all.